All right, so in our last video, we talked about the vocabulary and how we can represent relations. And that a relation is a set of ordered pairs. That now we're going to talk about, or we're going to write the set of ordered pairs that corresponds to each mapping diagram. So on this one, they're giving us the maps, and we're just going to write the list of ordered pairs. And so when we start, remember, for it to be an ordered pair, you have to have the it within parentheses. So when I'm making a list of ordered pairs, I make these nice curly brackets sometimes, right? And I mean, do your best. No one's saying they have to be perfect. And then I put parentheses, and then I'm going to put my input, so -2, comma, my output is 3. And then our next point, -1, comma, 2. And our next point, and notice I'm separating them with commas, our next point is 0, comma, 1. But it is important that for each point I put them in their own set of parentheses. And our last point in this relation is going to be 1, comma, 0. And then I'm going to close with another curly bracket. That I have now written my set of ordered pairs that correspond with the mapping of A. So then for B, I'm going to do the same thing. I'm going to start with my curly bracket, 0, comma, 1. So 0, comma, 1. And then we're going to go to 1, comma, 2. And then 2, comma, 2, because again, the arrow points to its output. And then our last one's 3, comma, 4. And I close my parentheses. So that is my set. And these curly brackets, they represent, in the math world, they represent sets. And so that is my set of ordered pairs. So for this mapping, they represent this relation right here. Now for C, again, I'm going to do 1, comma, and 1 goes to -1. And then 1, comma, and it also goes to +1. And then we have 4, comma, 2, and 4, parentheses, 4, comma, -2. And I'm going to close my curly brackets. I've got everything in parentheses to represent that they're ordered pairs. And this one, that is my set of ordered pairs for the relation. Now, I know this doesn't talk to us about determining if it's a function, but in our last video we talked about how a function has, for every input, there's exactly one output, right? So if I look at A, each input goes to only one output. So each of the inputs has an arrow to one output. So A we would consider a function, because for every input there is one output. Okay, so another funny way to think about it is our inputs do not cheat on our outputs, right? There's no two timing. So I'm going to look at B, and for each input, so each X value goes to one Y value. And I know this one we sit there and go, well, but 1 and 2 both go to 2. I never said that our output couldn't cheat on our input. What makes it a function is that our input cannot cheat on the output. And so B is a function because, again, each output only has one input. Now let's look at C. 1 goes to both -1 and 1, and 4 goes to both 2 and -2. But really, it only took for this to not be a function was for the one of these to go to 2 Y values. So our 1 and our 4 in this case are both cheating on our outputs. And so this is not a function. So again, to be a function, just a reminder, function, each input has exactly one output. There is a double standard. Inputs cannot cheat, outputs can, okay? All right, moving on to our next slide. Oh, so here we are talking about a function. So each input has exactly one output. Input, exactly one output. And so this one is a function. This one is not a function. And again, the reason is for each input here, there's exactly one output. But for each input here, there are two outputs. So that's how we want to remember it. All right, so example 2. Which relations are functions? Use a mapping diagram to explain your reasoning. So we can look at lists of ordered pairs and determine if it's a function or not. And the reason is we would only want to see one of each x value. So here we have 0, 1, 2, 3. This is going to be a function because none of my x values repeat. Now to make so this is going to be a function, and then to make that mapping diagram, I'm going to put in my first one 0, 1, 2, 3, because those are my x values, my domain. And then in my next one, we have 1, 4, 5, 7. 1, 4, 5, 7. Those are my range values, my outputs. So 0 maps to 1, 1 maps to 4, 2 maps to 5, and 3 maps to 7. And if you ever did have a repeat number, you would only write it once. In that, like we did have 1 and 1 in each, but they're in two separate. One was output, one was input, one was output. So I will write both of those, but if I had two of the same outputs, I would only write it once. So let's look at this one. Oh, look. We have a lot of the same outputs, but when I look at my inputs, and this is the most important to determine if it's a function, I only have one of each, right? So -2, -1, 0, and 1. And so since there's only one input, meaning each of these inputs have their own output, this one is going to be a function. And that's hard to believe because they are all going to 0. That's my only y value. But remember what makes it a function, that each input has exactly one output. And so each of these inputs has exactly one output, and that's what makes this a function. It would be different if I had two -2s and something other than a 0, and it was a completely different point. All right, C. Here we're going to make our 0. Oh, we have, okay, so 0, 0, so I'm only going to write it once, 1, and 3. Now, because that happens, I had 0 twice. I already know this is not going to be a function. Not a function. And I should say, I have 0 twice with two different y values, and that's what makes it not a function. Okay, here we have -1. I'm going to put the 2's next, and then the 3. Okay, I like to put mine in order. So I'm going to draw 0 to -1, and then 0 to 3, and then 1 to 2, and 3 to 2. But again, because that 0 is going to two different numbers, this is not a function. All right, last slide for this video. Is each relation a function? And explain. And again, you just have to look, do I have an input going to two different outputs? So A, look at this. We have 1 in here twice going to two different numbers. So this is not a function. And the reason is because 1 goes to 3 and 2. Or another way you could say it is my input does not have exactly one output, or whatever Math Excel has as an option for you to choose. All right, so now I'm looking at this next one. My inputs, -3, -2, -1, 0. None of them repeat. My outputs repeat, but my inputs do not. And so this is a function. And the reason, each input has exactly one output. Okay, so now looking at this one, 0, 1, 2, 3. So my inputs, there's only one of each, and there's only one of each my outputs, and so this is a function. And again, each input has exactly one output. I used to tell my high schoolers they could write that the x values are not two timing on the y values, but MathXL has the answers for you. So in our last video, it should be extra short. We're just going to talk about how you can tell whether a graph is a function or not. So until then.